Okay. All right, so now what we're going to do is look at this question, and we're going to look at the behavior of this polynomial. 2x squared minus 2x minus 3. Let's say that we don't know how this graph is going to look like. What we can do is plug in some points. So let's say we start at -2 and we go all the way up to 2. Okay, so we can just do this in our minds. It should be pretty fast. So 2 times -2 squared minus 2 times -2 minus 3. All right, let's start with one number at a time. So -2 squared is what? 4. Okay, 4 times 2, 8. Everybody, come here. All right, 8, and then -2, so that's a plus 4 is 12. Thank you, Davis. 12, and then -3 is 9. All right, so first number is 9. Go ahead and do the rest, and then I want you to plot those points. The numbers are 9, and then 1, -3, -3, 1. Okay, so -2, 9, -1, 1, 0, -3, 1, -3, 2, 1. All right, this is going to be a parabola, right? So we're probably going to connect the points. Something like this. We don't really know how it's going to look like, but something like that. Now, let me ask you a question. And let's have you talk to your partner on this because it helps. Let's move some people around. All right, so the question is, where might a 0 happen? 0 is where the function crosses the x-axis. So between which two x values will there be a 0, and how do you know? So talk to your partner. Between which two x values will there be a 0? Like, it has to cross the x-axis, and how do you know? Okay, let's see. McKenna and Eunice, what do you guys say? Between -1 and 0.
And then between 1 and 2.
Why?
Because it crosses it.
Because you can physically see it. Okay. Anybody else have any other thoughts? No? You're like, this is how we drew it, so it must work that way? Okay, now let me ask you a question. Let's say there is no graph. Let's say all you see is this. I'm going to erase this. Yep. Okay. And this part is just 9, right? This is just 9. So if you only have this table, between which two x values will there cross a, will this function cross the x-axis, and how do you know? If all you see is this, there is no graph that's shown. Okay, talk to your partner, or you need a little time to talk to your partner, or no?
We know it's between -1 and 0. You look at the y value.
You look at the y value, and what are you looking for?
It goes from like positive to negative. So
It went from positive to negative. Okay, and then here, and you went from negative to positive. So if you have two x values where the y values are positive and negative, then it has to have crossed the x-axis, right? Okay, then how about this one? Let's see. Let's say -2, -1, 0, 1, 2 again. Let's say it's -3, 1, 0, -1, -3. Okay, talk to your partner again. Between which two x values is the graph going to cross the x-axis? All right, so the Evan, Trey, and Blake group, what'd you guys say?
-2 to -1.
Okay.
And then also -1 to 0.
-1 to 0. Okay. Well, 0, 0 is obviously crossing. Anyone else have anything different? Yeah, it has to cross the x-axis. Where does it have to cross the x-axis? Well, yes, 0, 0. Besides 0, 0? All right, this is a little interesting. Well, let's graph it and look at it. So -2, -3, -1, 1, 0, 0, 1, -1, and 2, -3. So you're saying that it has to cross the x-axis this way, but what if it's like this? So what is the requirement that it has to cross? Not a parabola. What's the difference between these two graphs? Huh? Could be polynomial, but there is something that's different between these two graphs. That's very different. Yes, yes. You can see that the one on the right is continuous. On the left, it's not continuous. When it's not continuous, it's not guaranteed. Because continuous means it has to connect. Discontinuous means there is no guarantee that it has to connect. So therefore, we cannot guarantee that if there is a positive value and there's a negative value, it must connect. Does that make sense? Okay, so this is a very important theorem, which if you do calculus next year, you will learn it. It's called the intermediate value theorem. That says a few things. First, if the interval A to B is continuous, that is a very, very important requirement. It has to connect everywhere. Okay, so first, it has to connect if this interval is connected. The second thing, and that f of A and f of B have opposite signs. So the y values have opposite signs. So first, it's connected. Second, the y's actually have opposite signs. Then the conclusion. The conclusion is that there must be an x value so that f of c is equal to 0. So there is an x value c so that it will cross the x-axis. Okay, let's have you guys practice telling your partner. So, without looking at the theorem, let's have the people on the left tell the people on the right the two things that's needed for this theorem to work. Now the people on the right tell the people on the left what is the guaranteed result. How are you guys? Okay. Okay. All right. The last thing we're going to do is we're going to use our calculator to find all the real zeros. So let's look at this function just as it is right now. How many zeros are you expected to see? 4, because it's 4 degrees, right? Okay, so use your calculator. You should be able to find 4. If you don't see 4, then that means something is going on. You might have to zoom in, but you have to rely on looking at the equation and that degree to tell you how many you should see. Okay, go ahead and do that. If you forgot how to use the zero, find the zeros, let me know. I will show you. So you want to round to at least the thousandth. So first one is negative 3.0997. Second one is 0.5. And then 1.133. And then 1.367. Any questions on finding these 4?